Hello everyone, welcome to the second part of the video series where we are going to develop a to-do list web application in C. So this is where we got in the previous video. We have got a web server running, it's listening on port number 10,000, and when we make a request to the server, it just prints that we got a connection from this IP address because I'm in the same machine and the source port. So now what do we do from here? So we have a connection, we have the information about the client. Now we can try to receive some messages from the client and print it. For receiving the messages, first we have to have a buffer. Let's define a buffer. Let's say let's define a constant called buffer size. Actually, let's add 1 to this so that we can use it to null terminate the string in case it happens that the request size is exactly the buffer size. So we have to define this. Let's say 124. We can increase this. I think it's fine for now. Or let's make it big. Alright, so we have buffer for receiving the messages. I think I'll just make a function to take care of this, and I'll also move this here. Don't forget to free the memory after using it. At some point we have to move this part into a separate thread so that it can handle multiple connections at the same time. That's why I'm programmatically declaring this array and freeing it afterwards. Otherwise I would just make it static. Okay, so we have the buffer ready, and let's make a function. So we'll move the logic for receiving the data in a separate function because it involves having another loop, receiving it in chunks, etc. So it's better to move that there. So we'll need to pass the client file descriptor and of course the buffer. So this method is going to receive data from the client and store it in the buffer, and it will return the number of bytes received. So we can use this to check whether it was able to receive the data. So I'm just gonna do a checks equal to 0. Let's say on a okay, and we'll continue to listen to more connections. Alright, and we can just print the buffer. Let's do a /n. Okay, so we are already flashing print here, so it will flush everything. Then close the pointer, close the file descriptor, and also free the buffer. Okay, I think it looks good. We just had to define this function, receive request data. So I'll have to declare it at the top. Request data. Actually, what I can do is I can declare it in the header file, even though this, oh no, actually I'll just keep it here because we don't want to export this function to the other main function. This is something internal. So let's just define here, it takes a integer and buffer, actually const, let's not modify the buffer. Okay, we just have to see request data. Let's call it socket fd const char star buffer. Okay, so we have the buffer pointer here and the socket here. So we'll need a variable to keep track of the total number of bytes. Okay, now we need a while loop. So what we had to do is we had to start receiving messages from the socket. So how it works is, since this is a TCP connection, we are going to receive messages in chunks. So for HTTP, when you're making like small requests, you will most likely get everything in a single message. But if you're making a like large request, there's a good chance that you will receive it in multiple chunks. So we have to loop through the receive. We have to do an infinite loop and keep listening for messages until it's done. Okay, so we need to use the receive function. So it returns a sist bytes received, receive socket fd. Let's just let's check the documentation of the receive function quickly. Receive c. Okay, so receive takes a socket file descriptor, takes a buffer length, which is the maximum size it can receive, and a bunch of flags. Okay, so we have the socket file descriptor, that's good. And then we have to pass, let's make it if I can type. So we need to pass the buffer, but since we are appending to the buffer, we need to add total bytes received. So this will make sure to always append at the end. Okay, and then we need to pass the buffer size. Okay, so so each time we are going to receive a chunk, it's going to add to the buffer, and each time it will make sure to append to the buffer by adding the buffer pointer with the total bytes received so far, and the total size will also shrink by whatever we received so far in the buffer. Okay, now we need to have a bunch of comparisons. I'll just okay, let's keep it like that. So if the bytes received is less than 0, that means there is something wrong and you are not able to receive any data from the socket. So this is an error which says unable to receive data from the socket. And then we can return the -1 back, so we can validate it from there itself. Actually here let's do like a less than equals to 0. Okay, so it covers both. Okay, now in case the 0, this is a special case. So if it is 0, that means the client has closed the connection and did not send anything. Break. So it can happen that actually this is a successful condition. So it means the client has finished sending whatever it had to send, and it's not waiting for anything in response. So, or it just closed the connection. So it means the client has already finished sending the messages, or it has nothing more to send. So it's a break. We'll break here, and then whatever we have so far in the buffer, we can turn it back to the caller. Okay. So we have the buffer with messages. Now what we're going to do is, let's add a string terminator at the end. So in the buffer we have the total bytes received. Oh no, so we need to add the bytes received. So at the end of the buffer we are going to append a null character here. So this is why we had to add an extra here, if you remember correctly. So this is going to terminate the string in this buffer. So in the next iteration in this loop, if it is not finished yet, it's going to continue, and it will replace this. It will start appending from this point. So at any point, if the while loop is broken, we are going to get a complete string with the null terminator at the end. Okay, now the interesting part. So as per the HTTP specification, so we need to somehow detect if the client has finished sending its messages. So what's going to happen is that the client will send a GET request, and then it's going to wait for a response. So we need to be able to detect when the message has finished from the client, because it's not going to close a request until it receives a response, or we close the socket. So as per the HTTP standard, I think I have a example here. So this is how a typical request looks like in HTTP specification. You have a GET, then host parameter connection. These are all headers, and if it is a post request, you can also have like more at the end. So the important part is when it finishes the request, it's going to send a /n. Actually not a /n, but a /r/n/r/n. So by checking whether it has sent that already, we can verify whether the client has finished sending its message or not. This is a nice trick when we are doing HTTP server. So let's add a comment to make it clear. Oops. Detect end of HTTP request. Okay. So here let's use say str function. So this is going to check for a substring, and so since we are doing inside the while loop, we only have to check within the last set of bytes received from the client, so we don't have to check the whole buffer. Just some performance improvements. So let's say total bytes received. So this is the beginning of the buffer where it received the data. Okay, so we have to check whether it has /r/n/r/n. So this is the indicator of the end of it. So this will make sure whether the last received chunk has this present or not. If it is present, we'll just total bytes received equals to bytes. We are going to return back, so we are going to break the loop here, but don't forget to append this here so that we can return it back to the caller. So this is a successful condition. We are going to update this variable and break from the loop. Okay, so if it has not happened yet, that means we are still receiving data, and there are more data to come probably. So we'll just update the loop variable and let it continue. So as a safeguard, we also need to check whether our buffer is full. So if the total bytes received is greater than equals to buffer size. So if for some unfortunate reason the buffer is not big enough to accommodate everything, we'll just break it. So remember, here we already terminated the string, so we are still good. It's just that the buffer is going to contain like a part of the request, but I think it's still good to have that safeguard in place. So we have everything. Let's return total bytes. I don't even know if this is very useful, but let's keep it there. Okay, let's try building. And as usual, it's not cost, it's const. Okay, again, not cost. Printf buffer, forgot a semicolon as usual. Okay, include string.h. Okay, we need the string.h for substring. All right. Oh, okay, I didn't know it was not possible to manipulate the inside of a buffer if you use a constant. It's good to know. Let's remove that part. Too few arguments to function receive. Interesting. Socket fd buffer size. The last parameter. What was it? Flags. I don't know if we need any flags. Flags argument is formed by ORing one or more of the following values. Message, CM message, don't wait. Okay. Error queue, peak, trunk. Interesting. I think for now we'll just leave it as 0 and we can check later. Hopefully. Okay, perfect. Now let's make a request. Perfect. So we still have an empty reply from the server because we're not sending back anything, but on the bright side we have the whole get request printed here. So we have a get header, host header, user agent, and accept, and here you can see that there is a couple of new lines afterwards. And I would try using http spy. So this will have a bunch of different headers, so it has a connection keep alive, user agent, etc. Let's also try a post. So in a post request you have a post instead of get, and you can see the path here. Pretty much everything is same. Oh, and you also get a content length because it is expecting to send some data in the post request. Let's do some path variables. I don't know. Actually I need to put this in quotes because it has. Okay, so we have a whole path. Pretty interesting. I would also try adding some variables here. Let's see what happens if I post with some data. So got a connection, post, content type. Interesting. So we still have the headers, but that's it. It has content length, but it did not print this part. Oh, actually it did. Interesting. So when I make a post request with some parameters, it becomes part of the request, and you can get it here. So now we have the whole request body on the server side. So now what we had to do is parse this. It's going to be interesting. So we have to read this line by line, sorry, not here, from here. And the first line is the request parameter, post get method, route, and the HTTP version. And from there it starts the headers. So we have the key value pairs. So we had to split each line based on this colon, and then convert it into key value pairs. So I would use a map structure here. I think it's a bit of an overkill. Maybe just a simple array with a key and value should be enough. So we'll figure out the data structure for this and have a method to get the headers, because it's going to be used for later. We'll have to check the accept type, content type, and the content length. So from the content length we will know how much we had to wait for, how many bytes we have to read after this. It's quite interesting. Okay, so that's it in this video. In the next video we will figure out how to do that. So thank you.